What if the biggest secret to our planet's future is buried under 2 miles of Antarctic ice? For decades, scientists have known about subglacial volcanoes, but only now are we truly beginning to understand the immense power they hold beneath the frozen surface. Prepare to have your understanding of Earth's climate fundamentally reshaped. We all know that Antarctica is home to some of the coldest and most inhospitable environments on Earth. Its vast, icy expanse is the last place most people would expect to find the kind of volcanic activity that shapes our planet's surface. Yet beneath the thick ice sheets, a hidden world of subglacial volcanoes is quietly at work. These volcanoes, known only to a select few, are playing a far more significant role in our planet's climate than we could have ever imagined. Today, we are rediving deep into the Antarctic ice to uncover the hidden volcanic giants that could hold the key to understanding climate change, shifting ice sheets, and the way our Earth's systems interact on a global scale. It is time to look beyond the frozen surface and reveal the hidden heat that could change everything we know about our planet's future. Imagine an entire volcanic range, buried under 2 miles of ice, so massive and secretive that it defies our usual understanding of volcanic activity. Welcome to the world of Antarctic subglacial volcanoes. These hidden giants, scattered across the vast land of Antarctica, are so powerful and large that they dwarf some of the most well-known volcano chains on Earth. The first question that comes to mind is, what exactly are subglacial volcanoes, and why haven't we heard more about them? Subglacial volcanoes are exactly what their name suggests: volcanoes that exist beneath glaciers and ice sheets. These volcanoes are often located along the same tectonic boundaries and hotspots that produce surface volcanoes, but their eruptions and activity remain hidden beneath thick layers of ice and snow. Unlike terrestrial volcanoes, which erupt violently and send lava spewing into the atmosphere, subglacial volcanoes are typically hidden from direct view. Their eruptions tend to be less dramatic and often occur in a far more controlled manner, sometimes involving the melting of ice rather than the explosive release of magma. However, this doesn't mean that these volcanoes are any less significant. In fact, the sheer scale of this hidden volcanic activity in Antarctica is truly mind-blowing. While the volcanoes of the Pacific Ring of Fire or the Icelandic volcanic systems get much of the attention, Antarctica's subglacial volcanoes form a massive, largely unstudied range. Some estimates suggest that there could be as many as 138 subglacial volcanoes beneath Antarctica's thick ice sheets, making it one of the most significant and underappreciated volcanic regions on the planet. To understand the significance of Antarctic subglacial volcanoes, it's important to first explore how they form and why they're so unique. Volcanoes in general are formed when molten rock, known as magma, rises from the Earth's mantle through cracks in the crust. In most cases, this magma erupts through the Earth's surface, forming volcanic mountains, lava fields, and other geological features. However, subglacial volcanoes work in a different way. These volcanoes lie hidden beneath thick glaciers and ice sheets, where the pressure of the overlying ice makes it difficult for the magma to escape in a traditional eruption. Instead of erupting explosively, these volcanoes often melt the ice above them, creating pockets of water and triggering complex geothermal processes. In some cases, the heat from the volcanoes is enough to cause large-scale melting beneath the ice, potentially contributing to the movement of glaciers and the overall dynamics of ice sheets. This, in turn, has profound implications for the future of Antarctica's ice, its contribution to rising sea levels, and its overall role in Earth's climate system. While subglacial volcanoes may not be as visible or as active as their surface counterparts, their hidden activity can still have significant impacts on the environment. Researchers have begun to realize that these hidden forces may be playing a role in the melting of Antarctica's ice sheets, contributing to global sea level rise and potentially even influencing atmospheric conditions in ways we don't yet fully understand. The most significant question surrounding Antarctic subglacial volcanoes is their potential to influence global climate patterns. The relationship between volcanic activity and climate has long been understood, with eruptions that spew ash and gases into the atmosphere having the power to cool the planet by blocking sunlight. However, the effects of subglacial volcanic activity are far more subtle and less predictable. When these hidden volcanoes heat up and melt the ice above them, the effects can be profound. The heat from subglacial volcanoes contributes to the loss of ice, triggering processes that could lead to the thinning and retreat of glaciers. As the ice melts and glaciers move, it could destabilize ice shelves, leading to the potential for larger, more catastrophic events like the calving of icebergs or the collapse of entire ice sheets. This is where the climate impact begins to take shape. The melting of Antarctica's ice sheets is already contributing to rising sea levels, and the activity beneath the ice could accelerate this process. As more ice is lost from the continent, the global climate system is affected in ways that are still being studied. The loss of ice sheets could alter ocean currents, change the reflection of sunlight across the Earth's surface, and even impact weather patterns. In addition to the immediate effect of melting ice, there is also the potential for the release of methane and other greenhouse gases trapped beneath the ice. As subglacial volcanoes heat the ice, they could release these gases into the atmosphere, adding to the greenhouse effect and further accelerating climate change. While this process is still largely theoretical, the implications are profound. To truly appreciate the significance of subglacial volcanoes, we must delve deeper into their potential role in ice sheet dynamics. Antarctica's ice sheets are not simply static masses of frozen water. They are constantly shifting and responding to various forces, including the heat from below. Subglacial volcanoes provide one such force. Their geothermal activity can lead to a warming of the ice, causing it to slide more easily over the bedrock beneath. This sliding motion can accelerate the movement of glaciers, contributing to their overall thinning and retreat. This, in turn, can impact the stability of the ice shelves that float on the ocean, potentially causing them to break apart and contribute to sea level rise. In the last few decades, scientists have observed that some glaciers in Antarctica are accelerating in their movement, suggesting that forces beneath the ice, such as geothermal heat from subglacial volcanoes, could be playing a role. While more research is needed to fully understand the extent of this influence, the possibility that subglacial volcanoes could be impacting the ice sheets in this way is both fascinating and concerning. Despite their importance, subglacial volcanoes are incredibly difficult to study. Antarctica is one of the harshest and most remote places on Earth, and much of the land is covered by miles of ice. The thick ice sheets make it nearly impossible to directly observe what's happening beneath them. So studying subglacial volcanoes requires sophisticated technology and indirect methods. One of the primary methods for studying subglacial volcanoes is the use of seismic imaging. Scientists send seismic waves into the ground and analyze how they bounce back to create detailed images of what lies beneath the ice. This allows researchers to detect anomalies in the ice and identify potential volcanic activity. Another method involves drilling into the ice sheets to collect samples and directly measure heat flow beneath the surface. This process is incredibly difficult and time-consuming, as it requires drilling through thick layers of ice while ensuring that the samples collected are not contaminated. As technology improves and more research expeditions are launched, scientists are gradually gaining a better understanding of subglacial volcanoes and their role in Antarctica's overall climate system. But there is still much to learn about these hidden giants. And every new discovery brings us closer to understanding how they could reshape our understanding of Earth's climate. As global temperatures continue to rise and the impact of climate change becomes more pronounced, the study of Antarctic subglacial volcanoes is becoming increasingly important. Understanding the activity beneath Antarctica's ice could help scientists predict how the ice sheets will behave in the future and how much sea level rise we can expect. The role of subglacial volcanoes in melting ice and affecting global climate patterns is still being studied, but it's clear that their influence could be more significant than we once thought. As we continue to explore and study these hidden volcanoes, we may uncover even more about the forces at work beneath the ice, forces that could hold the key to understanding Earth's changing climate. The future of Antarctic subglacial volcanoes lies in our ability to study them more effectively. With advancements in technology, we may one day unlock the full potential of this hidden world beneath the ice, revealing how these volcanoes could shape the future of our planet. Antarctica's subglacial volcanoes are not just scientific curiosities. They could be hidden climate catalysts with the power to reshape the future of Earth's climate systems. From their ability to melt ice to their potential contribution to rising sea levels, these hidden giants have a profound impact on the global environment. As we continue to study Antarctica's subglacial volcanoes, we are gaining new insights into the complex and dynamic systems that govern our planet. The more we learn, the clearer it becomes that understanding the forces beneath the ice is crucial to understanding our planet's future. The hidden heat beneath Antarctica's ice could be one of the most important discoveries in the field of climate science, and as research continues, we may be able to unlock the full extent of its influence on Earth's climate and ecosystems.